Right, hi guys. This is a video all about the Creality Slicer software, which should come with your Creality printer. This will work for all of the Creality printers that are on the market, the complete range. Of course, we are interested in particular in this video in the Ender 3 Pro, which is the printer coming your way. So when you open the app, once you've downloaded it, it will appear as an application in your PC or laptop, as others will, and it brings you to this home screen upon opening. The first thing that you'll need to do is tell the software what printer you are using. So if you click here, Add Machine, there's some very simple instructions to select the Ender 3 Pro. It's literally 1 or 2 pages long. I won't go into it because it kicks me out of the video, but if you have any problems, then please get in touch. So once you've done that, all of the settings will then configure itself to be Ender 3 Pro orientated. So on the screen here, you can see that it's showing us the build volume of the printer, which is 220 by 220 by 250. And if we go into machine settings, you'll see here, I've got two for some reason, I'll just remove one of them. You'll see here the bed size and the build shape area. I'm not sure what this G-code flavor means, but it tells you there, but essentially you don't have to change anything. It's there by default, so that's just really for awareness. So what we need to do first and foremost is understand the options here on the left hand side. Again, it is simple like the printer itself, so you choose your material, be that PLA or ABS plastic. I just leave it as either the PLA or ABS at the top there. I don't know the difference between the two, so that should work fine by choosing those top two options. Beneath that, you've got the profile. Now the printer has the ability to either print slightly faster at a lower accuracy or tolerance, which is to 0.2 millimeters, or if you require a higher quality finish to 0.1 millimeter accuracy, then it will do that, but clearly at a slightly longer duration. 0.1 or 0.12 is probably the highest accuracy we can attain on this printer, but that's great. To be honest, it's good enough for general purposes. Beneath that, you've got print support structure, which I'll come on to later, and also platform adhesion, which again I'll touch on later as well. So the first thing to do is to import our model. So if we go to this load button here, I've got a number of STL files, which is the accepted format. So if we say click the cat and open, you'll see it loads in our model there. If I select it and hold with the left mouse button, I can move it around on the print bed area. I can then also load in other files as well. Again, this is another STL file. If I open that, it will pop that in, and I can move that around with the left button clicked. If I click on the right button on the mouse, I can spin round and view the objects in the print area. Now, you will have noticed up here that it was automatically loading. It's telling me now that printing this will take 2 hours and 1 minute. It will require 7.74 meters of PLA plastic, which is equivalent to 23 grams. So normally you buy plastic at half a kilo or a kilo worth, which is I think 50 meters or 100 meters respectively. So again, that is important to check you've got enough PLA or ABS plastic in your printer before commencing. The other button here just takes you to their website for additional information or help if you get stuck. But honestly, I just use YouTube or Google to resolve any issues I might have with the printer. Down here on the left hand side, you've got your rotate, scale and mirror options, which simply adapts or modifies the objects in your area. So if we go to rotate, you can see I can rotate the cat there 90 degrees if you like, in any direction. Again, it's quite basic, quite easy to use. we won't put in that direction. I can reset it as well, the button below, which takes it back to its normal position. If I click on the other objects, simply with the left button, I can do the same thing as well. We can also scale. So I tend to scale by using the unit values here. So if I want to make it, say, half the size, I'll put in 0.5 and it will scale the other two down respectively. Equally, I could put in the size if I want it to be sized by a particular dimension. So I could put in 30 millimeters there, and again it will change the other two. That's the uniform scale lock there, so if I take that off, I can stretch the item just in that one dimension. But if you want to keep obviously a uniform scale, then make sure this little key lock here is in a lock position. There's also a mirror function as well. So again, we can select an object and choose to mirror it either around the Y, Z, or X axis. And it is important to bear this in mind because you want to make sure the print is going to work out effectively and it won't have any overhangs. If I just show you what I mean by that, so if we just take our wrench again, scale it back up so it's correct size. Oh, let's take that off. Great, okay. So if we, for example, would import a model that perhaps wasn't flat on the bed, and it was up like this, you would have to put in a lot of support structure underneath in order for these parts to be printed. This is where the print support structure comes in. So if I click that button there, it will automatically load in some print support structure underneath the wrench here, such that I can print this. Now that's not brilliant, that's not what we want. I'll show you that in a second on the visualization, but it will result in the print having a lot more material than what we require, and also the need for us to remove it afterwards, which won't be an easy process. So on the right hand side here, you've got view modes. So if I go to layers, this will show you how the printer will print your parts, and it's telling me there's 416 layers there. And the nice thing is with this software, you see, we drag down and it will show you the layers it goes through from 1 to 416. So you can see the light blue underneath the wrench there is purely support structure, and that is not what we want because it's a waste of material. And yeah, the aim with all 3D printing really is to minimize the support structure and only include it where absolutely necessary. So there is some art to designing models that will be 3D printed. Avoiding it is not possible every time. Sometimes you need it, but there are tricks in the trade to overcome that through smart design, which is a common challenge across all 3D printing mediums. So there are other view modes here as well, X-ray, transparent, and the overhang. The overhang just highlights those areas that will need support. So it's basically saying the same thing as what the layers does here. But if we go back to the original, what I'm going to do, I'm going to click on that object and press reset, because it brought the object in nice and flat, and that will print fine in that orientation. Again, every time I do this, the software does recalculate how long and how much material I need for the print, which other softwares don't do. You have to manually do it yourself. So it's quite a basic interface. I don't use this software in particular because there's other ones out there which are going to give you more insight into the parameters, and I find it easier to use, but this doesn't mean that you can't use this one at all. To finish off, I'll just touch on the platform adhesion. So we have these different options called brim and raft, and these are simply introduced to either, well, I'll show you. So if we click Brim, this will add an additional plate, if you like, underneath your object. So if we go to View Mode and Layers, and we take it down to the base. Oh no, I was actually incorrect. The Brim one is where it will add almost like a peripheral layer around your object, and that will ensure that the edges of your object do not start to peel away from the bed. You may find this sometimes with objects when you start to print them. The temperature difference between the bed here at 60 degrees and the nozzle does, and as it cools, it does start to cause some peeling away of the object. And the Brim support structure here is being designed or introduced to try and inhibit that from happening. So that's what that does. And the raft is a little more robust. Again, let's let it recalculate. But this adds an entire thickness or entire base to your part. So it will be difficult to remove. You'd have to remove it with some utensil or a knife. But if you don't really mind having a base there, it is an effective way to ensure that your object is printed to the highest quality from the base upwards. But I don't tend to use that. I generally tend to use Brim, and other softwares have other options as well. I forget the name now, but I will go into that when I explore the other softwares in a separate video. So that's basically everything I wanted to show you on here, with the exception of the final operation, and that is to export it. So we import STL files, and we output by clicking this button here a G-code. So if I go to my USB, there you'll see just now it has exported the cat G-code file, and that is a file that our 3D printer will accept. As always, guys, any questions, just please leave them comments or get in touch one way or another.